Diameter of a binary tree. A binary tree is a graph where a node has at most two children. So this is a binary tree because it has at most two children, which is 0. This is also a binary tree because it still has at most two children. And even this is a binary tree. You know what's not a binary tree? This one, where it has three more than two children. So what do you think the diameter would be for this graph? So a diameter is the distance between two nodes, but like the largest distance between two nodes. So if you take this 1 1 1, the diameter here would be 3, right? And uh, and if you take diameter for something like this, um, something like this, diameter would be 1 plus 1 plus 1 plus 1 plus 1, right? Diameter would be 3 plus 2 5. But what if there is no the this node? Then diameter would be 1 plus 1. It would still be 5, but like you don't consider the left nodes, you consider the right nodes. And yeah, so we need to track two variables here, right? One is the depth, another is the diameter. Depth is the height between the first node to the end node, and diameter would be the entire length. There is a chance that the diameter of this tree is greater than the entire left tree. That's why we need to, if you look here, if you see here, diameter is 4 and depth is 2, right? By the time it returns to here, the diameter would be still 4 because diameter is the longest distance between two paths, and depth would be 3. So you return 4 to the end node, right? So that's why we have to uh, track both depth and diameter. So let's first write our helper class. It would look something like this, where there is a class called helper that takes depth of int and val diameter of the value int, right? Then if we have to return our solution somehow, right? So we'll have a function that's called diameter of a binary tree that will take the input of a tree node, which looks something like this, and returns an output of int, which is a diameter. And if we think of it, we return a helper function that takes root or node as the input and returns the helper class, right? So that function would look something like this, where there is a function called helper that takes root node or a node, any node actually, which can be nullable, right? And actually, yeah, it returns an int, which is, sorry, it actually returns a helper class that tracks both depth and diameter. So we'll write this in recursion because the recursion method is the best way to solve this. But we can also do it without recursion help, but like recursion would be faster, right? So let's think of this. So if we take, or actually let's take this help. So if we take any leaf node, what would be the diameter and depth of it? There are no nodes, so depth is 0. Because now there are no nodes, the diameter is also 0. And then you return it to the this node. The If you take this one as 1 and this as 2, the depth would be 1, so diameter also would be 1, right? Because it's the distance between two, distance between two nodes. And if we go here, depth is 2, diameter is also 2. Till here, this is the value that returns here. And this value returns the same, where it's 1 1 here, where it's 0 0 here, and here it returns something like 2 2. And we have to decide what's the diameter. So we add up whatever value we have in the left and whatever value we have in the right, which is 2 comma 2. And finally, we send the depth as greater depth between these two, either left and right, and diameter as addition of the left depth and right depth. So that's the logic we have to write. So the logic would be something like this. First, we write our base case. If our root or whatever node here that we get is null, then return a helper class that has both depth and diameter, right? So depth is 0, diameter is 0 for the leaf node, right? And if then uh, we get we get to call our recursion function, which again calls the helper function, and it passes the root node with left subtree. And similarly, we get the right of helper function for the right subtree, right? Now depth, sorry, depth would be, what did we say? It's the maximum of left depth and right depth. Because we have to pass it through, we'll give it an addition of this node too, right? So here we'll pass it as 3 and 4, right? So it's maximum of left depth and right depth plus 1. So depth is left. So here we receive a helper class, right? So we take helper class left depth plus right depth. Not plus, sorry. I mean, actually, let me write this back. Max of left comma depth comma right comma depth dot depth, right, plus 1 would be the value of depth. And what do you think the value of diameter would be? We discussed this, right? So let's see here. It's the distance between two largest nodes. So it's 4 here, right? It's 4 here because left depth plus right depth. So, but here when you're passing it, your diameter can be 4, and this side diameter is 0, right? So it gets 0 0 here. So yeah, you have to decide between max of your left depth plus right depth, or your left diameter or your right diameter. And finally you return your helper class that has your depth that you calculated and the diameter that you calculated. And this should help you finally get finally return your helper with and finally return the entire diameter to your main method that is solving this. We can obviously solve this in another way too, where we don't use recursion. I'll teach that in the next video. Stay tuned. Thank you. Just to recap, so this is how our uh, tree node looks like, and we first have a helper class that takes both depth and diameter as its data class variables, and then we have a diameter function that takes root node as its node, and returns the diameter value. So we have a helper function that takes root node as its node and returns the diameter. And here's our helper function. If root node is null, which is when it has no leaves, or yep, when it has no leaves, it returns a 0 0 helper with 0 depth and 0 diameter. Our left node would then be, if not, it means it has some children, right? It may be left or it may be right. So we'll send our left root dot left to pursue the left tree, and root dot right to pursue the right tree. And then we get the maximum depth, which is max of left depth comma right depth, which are maximum and plus 1 to send it above. And then we get the diameter as I explained. Left depth plus, it's either left depth plus right depth or left diameter or right diameter. And finally, you return a helper function that consists of this depth and this diameter. And that should solve this problem.